Because sine and cosine functions are transformations of each other, both of sine and cosine functions are called sinusoidal functions. Let's explore various knowledge about that. Complete the table below and observe, make an observation. So f of x is cos x. What is the range? We know that the maximum value is 1 and the lowest value is -1. So the range is -1 to 1. If it is 2 of cos x, that means it's double. That means it is vertically extended to, the range would be -2 to 2. If it will be half cos x, it will be compressed to, vertically compressed between the range of -half to half. In general, the value of any function a sine x and a cos x, where a is non-zero obviously, because if it is 0, it will just become a zero function, always satisfies the inequalities like this, that a sine x would lie between -1 a and a cos x would lie between -a and a. The value of absolute value of a is called amplitude. That is what we say as amplitude, because it dictates the height of the graph from x-axis. In terms of transformation, it determines the vertical stretch and compression. Why do you think absolute value, amplitude is the absolute value of A? Because this is the, say we have the sine curve, right? So sine curve is this. So the height of the curve of one high hill, or the depth of 1. So the absolute value, right? So we have the amplitude is the absolute value of A. Complete again, let's look at these functions, cos of x, cos 3x, and cos of 1/4 x. What is happening to the period? The cos function's period is 0 to 2 pi. When it is cos of 3x, the horizontal compression is happening by a factor of 3. That means the period would be 0 to 2 pi by 3. And if it is cos of 1/4 x, then it will be horizontal extension, because 1/4 is less than 1. So x would be lying between 0 to 8 pi. So we have the period change according to the coefficient of x. So in general, if sine of omega x is there or cos of omega x is there, and a is positive and omega is positive, then we have the periods to be 2 pi by omega. Represent how long it takes to draw one cycle of the graph. What is the period of the graph? How long it takes? One full cycle of the graph. Let's see. So we can define this as a theorem. If omega is positive, the amplitude and the period of this curve, or a cos omega x, is amplitude is given by absolute value of a, and the time period, that means one full cycle, is given by 2 pi by omega. What is omega? Omega is the coefficient of x in these functions. So let's use that theorem to find the amplitude and period of the following sinusoidal curves. The first one here, let's compare this to a cos omega x. That is your standard function. Comparing these two, a is -4. That means amplitude is equal to absolute value of -4, which will be 4. Amplitude is always positive. Because omega, comparing these two, is 3, that means the time period will be given by 2 pi by omega, which is 2 pi over 3. Let's look at this second part. Y is half sine of -pi x. Now see, this theorem applies when we have omega is positive. In this case, omega is not positive. So we can apply our rule, right? Even an odd rule. We know that sine of -x is negative sine x. Sine x is an odd function. That means this can be written as -half sine pi x. Half. Negative can be taken out. Now compare this to a sine omega x. When you compare these two, a is half, and omega is pi, which is a positive number. Remember that omega has to be positive. So amplitude is equal to absolute value of half, which will be half, and time period will be 2 pi by omega, which will be 2 pi by pi. So the amplitude of this function would be 2. That means one whole cycle of this function will be completed in 2 units, 0 to 2. In addition to graphing sinusoidal functions using transformation, the periodic nature of these functions can be used to graph using key points. So now we are going to learn how the key points can be used. What are the key points? So here they are marked. 0, 0, the graph of sine function. Let's look at sine function first. At 0, 0, the graph of the sine function is 0. At pi by 2, it reaches the highest point. So I can do this. I can divide this graph at these key points. So the first key point is at 0. The second is at pi by 2. Then third is at pi. Next we have 3 pi by 2. And the last one is at 2 pi. So one whole cycle length is divided into 4 equal intervals. 4 equal intervals. The first, second, third, and fourth. It's divided by the 5 total key points. 1, 2, 3, 4, and 5. So this graph always behave like that. All the sine functions graph behaves like this. They have 5 key points. The first key point is the lowest value, the 0. The second key point is the highest value. Then it goes to 0. And then it goes to the minimum value of -1. And then the next it goes to 1. Similarly, for the cos function, the key points are again at 0. But at 0, it is at the highest point. At pi by 2, it is at 0. Then at pi, it is at -1. At 3 pi by 2, it is at 0. And at last 2 pi, it is at 1. So again, we have total 5 key points which divide the whole time period into 4 equal portions. Okay, so we can use this idea to plot our graph. Each graph can be broken into 4 subintervals: 0 to pi by 2, pi by 2 to pi to 3 pi by 2, and 3 pi by 2, 2 pi. So let's use this strategy to draw our graphs. Okay, so the first step is to determine the amplitude and the period of the sinusoidal function. Let's look at that. Let's use this example and learn using those steps. The first step is to determine the amplitude. What is amplitude? Compare this with A times sine omega x. Omega is positive, so we can work. A is, comparing these to 4, omega is 2. So the amplitude is absolute value of A, which means absolute value of 4, which will be 4. What is period? The period is given by T is equal to 2 pi by omega. 2 pi by omega is 2. That the period is pi. Now, divide the interval 0 to time period. That means divide this interval into 4 subintervals of same length. So this total length is pi. If you divide in 4 portions, that would be, each would be of the length pi by 4. That means we have to divide this 0 to pi long time period interval into 4 portions, each of the size pi by 4. So I would say 0 to pi by 4, pi by 4 to pi. If we add pi by 4 to 2 pi by 4, it will be pi by 2, pi by 2 to 3 pi by 4, and 3 pi by 4 to 5. Okay, so we have divided. These are the key points. So what are the 5 key points? 0, pi by 4, pi by 2, 3 pi by 4, and 5. So our graph We start from 0, then we have pi by 4, then we have pi by 2, 3, pi by 4, and pi. These are the 5 key points. This function, what kind of function is this? This function is sine function, and the amplitude is 4. That means the highest value it goes up until is 4, and the lowest value it goes is negative 4. Because this function is 4 sine of 2x, what is sine of 2x? It is a sine function, right? Sine function at first key point is 0. At the second key point, it goes the highest. At the third key point, it becomes 0. At the fourth key point, it is the lowest value of the graph. And at the last key point, it is 0. So just by using the key point, I can join my curve like this. So we can draw just one cycle, and we can obviously extend this cycle. The cycle length is 0 to pi. So the pi length, right? So the next cycle will be finished at 2 pi. The next cycle will be finished at 3 pi. So we can just, if you could just pick it up and put it repeatedly over the line from left to right, we can get the whole graph. So the graph can be easily drawn. Let's revise what we did. We found the amplitude and period of the function. So we got the interval because this interval looks like 0 to t. T is 2 pi by omega. We divide that into 4 subintervals of same length. So I find that length by dividing t further by 4. Use the end points of the subintervals to find 5 key points. Plot the 5 key points and draw a sinusoidal graph, and extend the graph in each direction to make it complete. So we followed all these steps to graph this function. Let's take one more example. We have to graph negative 5 cos of negative pi by 2x. The first thing, cos is an even function. Cos is even function, meaning cos of negative x is cos of x. We are doing this because the omega has to be positive. So this can be negative 5 is outside. Cos of pi by 2x. Okay, the negative is adjusted because of this cos function. Now compare this to a cos omega x. We have a is equal to negative 5 and omega is equal to pi by 2. Let's find amplitude. Amplitude is absolute value of a, which will be absolute value of negative 5, which will be 5. Time period t is 2 pi by omega. In this case, omega is pi by 2. So that would give us 4. So the time period is 4. That means one full cycle will be from 0 to 4. I have to divide that into 4 equal subintervals. Each would be of the length 1, right? The total length is 4. So each would be of the length 1. So 0 to 1, 1 to 2, 2 to 3, and 3 to 4. What are the key points? The key points are 0, 1, 2, 3, and 4. Now, let's see what we know. We know that this is a cosine graph and there is a negative, so it has to be reflected. Okay, so this is x-axis, we have y-axis. The amplitude of the graph is 5. That means the highest it goes is 5 and lowest it goes is at negative 5. 5 key points are 0, 1, 2, 3, 4. This is a cos function. So at 0 it is highest, but because of this negative 5 it will be reflected. So we have at 0 it is negative 5, 1 it is 0, at 2, 5, 3 and 4. So the one whole cycle of the curve would look like this. And we can extend it to both sides to get the complete graph.